Picture this. At this very moment, as you sit listening to these words, trillions of quantum particles in your body are existing in multiple states simultaneously, vibrating between possibilities like ghostly echoes of what could be. Yet somehow, mysteriously, the world around you appears solid, definite, real. Your coffee mug isn't both empty and full. Your phone isn't simultaneously on and off. The universe has made a choice about what's real and what isn't. But how? How does the strange probabilistic realm of quantum mechanics transform into the crisp, decisive reality you experience every single day? The answer lies in one of the most profound and elegant processes in all of physics, quantum decoherence. Welcome to another gentle journey into the depths of scientific wonder. I'm here to guide you through one of the most beautiful mysteries of our universe, the bridge between the quantum and classical worlds. Tonight, we're exploring how reality itself emerges from the quantum foam, how the universe decides what becomes real, and why your everyday experience feels so different from the bizarre quantum realm that underlies everything. Before we begin this exploration, take a moment to settle in. Perhaps adjust your position, let your breathing slow, and prepare to drift through ideas that will gently reshape how you see the world around you. This isn't just a story about particles and waves. It's a meditation on the nature of reality itself, told through the lens of one of physics' most profound discoveries. To understand quantum decoherence, we first need to appreciate just how strange the quantum world really is. Imagine holding a coin in your hand. In our everyday experience, when you flip that coin, it follows a predictable arc through the air and lands either heads or tails. The outcome might be uncertain to you, but the coin itself is always in one definite state or another throughout its journey. Now step into the quantum realm. Here, particles don't behave like coins at all. They can exist in what physicists call superposition, a ghostly state where they are simultaneously in multiple conditions at once. An electron, for instance, can spin both clockwise and counterclockwise at the same time. A photon can travel through two different paths simultaneously. It's not that we don't know which state the particle is in, it's that the particle genuinely exists in all possible states until something forces it to choose. This quantum superposition isn't just a theoretical curiosity. It's been demonstrated countless times in laboratories around the world. Scientists have created particles that are in two places at once, atoms that spin in opposite directions simultaneously, and even larger objects existing in contradictory states. Yet when these same scientists try to observe these superpositions directly, something remarkable happens. The moment they look, the superposition vanishes. The particle suddenly snaps into one definite state, as if the universe has finally made up its mind. This phenomenon puzzled physicists for decades. If particles can exist in superposition, why don't we see chairs that are simultaneously here and there, or cats that are both alive and dead? Why does the quantum world seem to follow one set of rules, while our everyday world follows another? The answer, it turns out, isn't that quantum mechanics stops working at larger scales. Instead, there's a beautiful process that transforms quantum strangeness into classical certainty: decoherence. As you contemplate this mystery, notice how it mirrors something profound about your own experience. Right now, your mind might be holding multiple thoughts, multiple possibilities, multiple interpretations of what you're hearing. Yet somehow, you're able to focus on one stream of consciousness, one coherent narrative. The quantum world and your inner world might not be as different as they first appear. The key insight that revolutionized our understanding of quantum mechanics came when physicists realized that no quantum system exists in perfect isolation. Every particle, every atom, every quantum object is constantly interacting with its environment in ways both subtle and profound. These interactions, rather than being mere background noise, are actually the primary sculptors of reality as we know it. Think of a quantum particle as a delicate musical note, pure and precise when played in perfect silence. But the real world is never silent. There are always other sounds, other vibrations, other influences. In the quantum realm, these environmental influences aren't just distractions. They're active participants in determining which possibilities become real and which fade away like half-remembered dreams. The environment includes everything from stray photons of light bouncing around, to air molecules jostling against surfaces, to the subtle vibrations of the Earth itself. Each of these environmental factors interacts with quantum systems, and through these interactions, something extraordinary happens. The environment begins to monitor the quantum system, extracting information about its state and spreading that information throughout the surrounding space. This process is remarkably similar to how gossip spreads through a community. Once one person knows a secret they might tell to others, those two tell 4 more, who tell 8 more, and soon the entire community knows what was once private information. In the quantum world, when a particle interacts with an environmental particle, information about the quantum system states begins to propagate outward. The environment becomes entangled with the quantum system, and this entanglement is the key to understanding how reality emerges. What makes this process so fascinating is its irreversibility. Once quantum information has spread into the environment, it becomes virtually impossible to gather it all back together again. Imagine trying to collect every molecule of air you've ever breathed, or every photon of light that has ever reflected off your skin. The information becomes so dispersed, so entangled with countless environmental degrees of freedom, that the original quantum superposition can never be reconstructed. This irreversible spread of information is what physicists call decoherence. It's not a violent collapse or a dramatic event. It's more like a gentle dissolution, a gradual transition from quantum possibility to classical certainty. The superposition doesn't disappear. Instead, it becomes so entangled with the environment that its quantum properties become unobservable, effectively invisible to anyone trying to detect them. To truly understand decoherence, we need to explore one of quantum mechanics' most mysterious phenomena: entanglement. When 2 quantum particles become entangled, they form a connection that transcends space and distance. Measuring one particle instantly affects the other, no matter how far apart they might be. Einstein famously called this spooky action at a distance, and it remains one of the most counterintuitive aspects of quantum theory. But entanglement isn't just a curiosity for physics laboratories. It's the driving force behind decoherence, the mechanism that transforms quantum weirdness into everyday reality. When a quantum system in superposition interacts with its environment, it doesn't just exchange energy or momentum. It becomes entangled with the environmental particles it encounters. Picture a quantum system as a dancer performing alone on a stage, moving through a choreography of multiple possibilities simultaneously. Now imagine that other dancers begin to join the performance, one by one. At first, the original dancer might maintain some independence, but as more dancers join and begin to interact, the performance becomes increasingly complex. Each new dancer becomes synchronized with the group, and soon the original dancer's individual movements become indistinguishable from the collective choreography. This is what happens when a quantum system becomes entangled with its environment. The system's superposition becomes part of a much larger, much more complex quantum state that includes countless environmental particles. While the superposition technically still exists, it's now so deeply embedded in this larger quantum state that it can no longer manifest the interference effects that make quantum behavior observable. The beauty of this process lies in its selectivity. Not all quantum states are equally vulnerable to environmental entanglement. Some states, particularly those corresponding to definite positions and classical properties, are remarkably robust against environmental disturbance. These are the states that survive the decoherence process, the ones that become the building blocks of classical reality. This selective preservation explains why we see objects in definite locations rather than spread out in superposition. Position-based states interact weakly with most environmental factors, making them naturally stable. Superposition states, on the other hand, are exquisitely sensitive to environmental monitoring, causing them to decohere rapidly and become unobservable. Take a moment to consider how this might relate to your own experience. In your daily life, you might notice that some thoughts and feelings seem to persist while others fade quickly. Some memories remain vivid, while others become hazy. While this isn't quantum mechanics at work in your brain, there's something poetic about how both quantum systems and consciousness seem to have natural selection processes that determine what persists and what fades away. One of the most striking aspects of decoherence is its incredible speed, particularly for larger objects. While quantum superpositions can persist for hours or even days in carefully isolated laboratory conditions, they typically vanish in fractions of a second when exposed to normal environmental conditions. This dramatic difference in timescales helps explain why quantum effects seem so foreign to our everyday experience. For a dust particle floating in air, quantum superposition would disappear in less than a trillionth of a second. For something as large as a grain of sand, decoherence would occur almost instantaneously, faster than any instrument could detect. These incredibly short timescales mean that large objects never have the opportunity to display quantum behavior under normal conditions. The relationship between size and decoherence time isn't linear. Instead, it follows a steep, exponential curve. Double the size of an object, and its decoherence time might decrease by factors of millions or billions. This is why quantum effects become increasingly difficult to observe as we move from individual particles to atoms, from atoms to molecules, and from molecules to the objects of our everyday experience. But size isn't the only factor that determines decoherence rates. Temperature plays a crucial role as well. In hot environments, particles move more rapidly and collide more frequently, leading to faster information exchange and quicker decoherence. This is why quantum computing experiments often require temperatures near absolute zero, where thermal motion is minimized and quantum states can survive longer. The medium surrounding a quantum system also matters enormously. In vacuum, particles can maintain superposition for extended periods because there are fewer environmental interactions. In dense materials or liquids, decoherence occurs much more rapidly due to the constant bombardment of neighbouring particles. Modern quantum technologies represent humanity's attempt to win the race against decoherence. Quantum computers must perform their calculations faster than their qubits lose coherence. Quantum communication systems must transmit information before environmental noise destroys the delicate quantum correlations. These technologies push the boundaries of what's possible when we try to harness quantum effects before they disappear into classical behavior. As you reflect on these timescales, consider the remarkable precision required for quantum effects to occur at all. The fact that we can observe quantum behavior, even briefly, requires an almost miraculous alignment of conditions. Every quantum experiment is a race against time, a brief window into a realm that usually remains hidden beneath the surface of classical reality. The process of decoherence doesn't just destroy quantum superpositions randomly. Instead, it acts like a natural filter, selecting which quantum states can survive in the real world and which cannot. This selectivity is one of the most elegant aspects of decoherence theory, explaining not just why quantum effects disappear, but why the classical world has the specific properties we observe. The environment acts as a kind of natural selector, preferentially preserving quantum states that correspond to classical properties like definite position, momentum, and energy. These preferred states have a special relationship with their surroundings. They tend to become less entangled with environmental factors, making them more stable and longer lasting than other quantum states. This environmental selection process, known as Ein selection, provides a dynamical explanation for why certain physical properties appear fundamental when they're actually emergent. Position, for instance, seems like a basic property of matter, but from the perspective of decoherence theory, it's actually a consequence of environmental selection. Objects appear to have definite positions because position-based quantum states are the ones that survive environmental monitoring. The implications of this insight extend far beyond physics. It suggests that the classical world we experience isn't the fundamental layer of reality, but rather an emergent phenomenon arising from the complex interplay between quantum systems and their environments. Reality, in this view, is constantly being constructed through countless microscopic interactions, each one contributing to the ongoing process of environmental selection. This perspective transforms our understanding of measurement in quantum mechanics. Rather than requiring a conscious observer or mysterious collapse mechanism, measurement becomes a natural consequence of environmental monitoring. Every interaction between a quantum system and its surroundings constitutes a kind of measurement, gradually extracting information and driving the system toward classical behavior. The selectivity of decoherence also helps explain why quantum mechanics and classical physics make consistent predictions for large-scale phenomena. Classical physics emerges naturally from quantum mechanics when we consider the effects of environmental decoherence. The classical world isn't separate from the quantum world. It's the quantum world after it has been filtered through the process of environmental selection. Consider how this might illuminate aspects of your own experience. Throughout your day, you're constantly making choices about what to pay attention to and what to ignore. Your consciousness seems to naturally filter the overwhelming complexity of sensory input, selecting certain experiences to preserve in memory, while others fade away. While this isn't quantum decoherence, there's something profound about how both consciousness and quantum systems seem to have natural selection mechanisms that shape what becomes real or remembered. The relationship between measurement and decoherence touches on one of the deepest puzzles in quantum mechanics, the measurement problem. Traditional interpretations of quantum theory required a mysterious process called wave function collapse to explain how quantum superpositions transform into definite measurement outcomes. But decoherence theory offers a more physical, more satisfying explanation. In the decoherence picture, measurement devices are themselves quantum systems subject to environmental monitoring. When a quantum system interacts with a measurement apparatus, both systems become entangled with each other and with their shared environment. The measurement process doesn't require any special collapse mechanism. Instead, it emerges naturally from the same environmental interactions that drive all decoherence processes. This perspective revolutionizes how we think about the role of observers in quantum mechanics. Rather than requiring conscious awareness or special measurement devices, quantum systems are constantly being measured by their environment. Every photon collision, every molecular interaction, every tiny vibration constitutes a form of environmental measurement that extracts information about quantum states. The implications are profound. If measurement is simply environmental monitoring, then the quantum to classical transition is happening everywhere, all the time. Reality isn't something that emerges only when humans decide to look. It's continuously being constructed through the countless microscopic interactions that fill every corner of the universe. This understanding helps resolve the paradox of Schrödinger's cat. The famous thought experiment imagined a cat that could exist in a superposition of alive and dead states until observed. But in light of decoherence theory, such a superposition would be impossible to maintain. A real cat interacts with its environment in countless ways, breathing air, exchanging heat, reflecting light. These interactions would cause decoherence so rapidly that the cat would never exist in a quantum superposition in the first place. Modern experiments have succeeded in creating Schrödinger cat-like states, but only with carefully isolated, microscopic systems and only for brief periods. The larger and more complex the system, the more difficult it becomes to prevent environmental decoherence from destroying quantum superpositions. The measurement problem also highlights the fundamental role of information in quantum mechanics. Decoherence theory suggests that information, rather than matter or energy, might be the most basic constituent of reality. The universe doesn't just process energy and matter, it processes information, constantly extracting, storing, and redistributing knowledge about the states of quantum systems. As you contemplate these ideas, you might notice parallels in your own relationship with knowledge and observation. When you pay attention to something, you're extracting information about it, potentially changing both your understanding and the thing you're observing. While this isn't quantum mechanics, there's something profound about how observation seems to play an active role in shaping both quantum reality and conscious experience. This brings us to a moment of pause in our exploration. We've journeyed through the strange landscape, where quantum possibilities transform into classical certainties, where the environment acts as reality's silent architect, and where measurement emerges from the fundamental fabric of physical interactions. But our story is just beginning. We still need to explore how decoherence manifests in specific systems, how it challenges our understanding of consciousness and reality, and how it shapes the cutting-edge technologies that may define our future. The quantum world has many more secrets to reveal, and decoherence is the key that unlocks them all. Take a breath and let these ideas settle in your mind. The universe is stranger and more beautiful than we ever imagined, and we're only just beginning to understand how the seemingly impossible quantum realm gives birth to the solid, dependable reality you experience every moment of your life. In the hushed corridors of quantum physics laboratories around the world, scientists are witnessing something extraordinary. They're watching reality make decisions. not in some abstract philosophical sense, but literally observing the moment when quantum possibilities crystallize into the definite, measurable outcomes that form our classical world. These experiments are revealing decoherence in action, showing us the precise mechanisms by which the universe transforms quantum strangeness into everyday certainty. Consider the double-slit experiment, perhaps the most famous demonstration of quantum weirdness. When particles are fired one by one through two parallel slits, they create an interference pattern on a detection screen, as if each particle somehow travelled through both slits simultaneously. This wave-like behaviour persists as long as no one tries to determine which slit the particle actually used. But the moment scientists place a detector near the slits to monitor the particle's path, the interference pattern vanishes. The particles suddenly behave like classical objects, each going through one slit or the other, never both. For decades, this experiment seemed to suggest that conscious observation somehow caused quantum superpositions to collapse. The act of looking appeared to fundamentally alter physical reality, but decoherence theory provides a more satisfying explanation. The detector itself is an environmental system that becomes entangled with the particle. Information about the particle's path spreads into the detector and then into the surrounding environment. This environmental monitoring is what destroys the quantum interference, not any mysterious effect of consciousness or observation. Recent sophisticated versions of this experiment have provided unprecedented insights into how decoherence unfolds. Scientists have learned to control the amount of information that leaks into the environment, gradually transitioning quantum systems from perfect superposition to complete classical behaviour. They've discovered that decoherence isn't an all-or-nothing process, but occurs smoothly as environmental entanglement increases. One of the most remarkable aspects of these experiments is their demonstration of einselection, environmental selection of preferred quantum states. Researchers have found that certain quantum states naturally resist environmental entanglement, while others succumb almost immediately. The states that survive are precisely those that correspond to classical properties like definite position and momentum. The environment doesn't just destroy quantum coherence randomly, it selectively preserves the states that will become the building blocks of classical reality. These laboratory observations have profound implications for our understanding of reality itself. They suggest that the classical world we experience isn't fundamental, but emerges continuously from quantum processes. Every moment, countless quantum systems are undergoing decoherence, their superpositions dissolving into classical definiteness through environmental interaction. Reality is being constructed right now, all around you, through mechanisms so subtle and rapid that they remain completely invisible to direct experience. As you consider these experiments, notice how they reveal something profound about the nature of knowledge itself. The act of gaining information about a quantum system fundamentally changes that system's relationship with the world. This isn't unique to quantum mechanics. In your own life, when you learn something new about a situation or person, that knowledge changes how you relate to them. Information has transformative power, both in quantum systems and in conscious experience. Perhaps nowhere is the practical importance of decoherence more evident than in the development of quantum computers. These remarkable machines represent humanity's attempt to harness quantum superposition and entanglement for computational purposes. But their success depends entirely on winning a race against time, performing calculations before environmental decoherence destroys the delicate quantum states that give them their power. Quantum computers operate using quantum bits, or qubits, which can exist in superposition states representing both 0 and 1 simultaneously. While a classical computer processes information sequentially, using bits that are definitively either 0 or 1, a quantum computer can explore multiple computational paths in parallel. The potential speed-up is extraordinary. Where a classical computer might need millions of years to solve certain problems, a quantum computer could find the answer in minutes or hours. But this quantum advantage comes with a price. Qubits are exquisitely sensitive to environmental disturbance. The slightest vibration, the tiniest temperature fluctuation, even stray electromagnetic radiation can cause decoherence, destroying the quantum properties that make the computation possible. Current quantum computers must operate in extreme conditions, cooled to temperatures colder than outer space and isolated from virtually all environmental interference. The coherence times of modern qubits, the duration they can maintain their quantum properties, typically range from microseconds to milliseconds. These might seem like impossibly short timescales, but they represent tremendous achievements in quantum control. Early quantum systems lost coherence in nanoseconds or less. Each improvement in coherence time opens new possibilities for quantum computation. Different quantum computing platforms face unique decoherence challenges. Superconducting qubits, used by companies like IBM and Google, must contend with electrical noise and thermal fluctuations. Trapped ion systems deal with laser instabilities and electromagnetic interference. Photonic quantum computers, which use particles of light as qubits, have the advantage that photons barely interact with their environment, making them naturally resistant to decoherence. However, they face other challenges in processing and storage. The race to build practical quantum computers has driven remarkable innovations in decoherence control. Scientists have developed error correction codes that can detect and fix quantum errors before they destroy computations. They've created new materials and fabrication techniques that reduce environmental coupling. They've even learned to perform quantum operations faster, completing calculations before decoherence can take hold. Recent breakthroughs have been astounding. Researchers have created quantum processors with hundreds of qubits, demonstrated quantum algorithms that outperform classical computers on specific problems, and achieved quantum error correction in real time. Each advancement brings us closer to the era of fault-tolerant quantum computing, where quantum computers will maintain coherence indefinitely through active error correction. The implications extend far beyond computation. Quantum computers are teaching us how to control quantum systems with unprecedented precision. The techniques developed for quantum computing are finding applications in quantum sensing, quantum communication, and fundamental physics research. We're learning to manipulate the quantum world with the same finesse that classical engineers manipulate mechanical systems. Consider how this technological revolution mirrors aspects of human consciousness and attention. Your ability to focus on complex tasks requires maintaining coherence of thought despite countless distractions. Like a quantum computer racing against decoherence, your mind must preserve delicate patterns of neural activity long enough to complete meaningful work. While the mechanisms are entirely different, there's something poetic about how both quantum systems and consciousness must maintain their special properties against environmental interference. One of the most intriguing frontiers in decoherence research involves biological systems. For decades, scientists assumed that the warm, wet, noisy environment inside living organisms would destroy quantum coherence almost instantly. life seemed too chaotic, too classical to harbour quantum effects. But recent discoveries have revealed that biology not only tolerates quantum behaviour, but may actually depend on it for some of its most essential processes. Photosynthesis, the process by which plants convert sunlight into chemical energy, appears to use quantum coherence to achieve remarkable efficiency. When light hits a photosynthetic protein, it creates an excited state that must travel to a reaction centre, where it can be converted into useful energy. Classical physics would predict that this energy transfer would be relatively slow and inefficient, involving random hopping from molecule to molecule. But experiments have revealed something extraordinary. The energy appears to explore multiple pathways simultaneously, using quantum superposition to find the most efficient route to the reaction centre. Even in the warm, chaotic environment of a living cell, quantum coherence persists long enough to guide energy transfer with near-perfect efficiency. This quantum enhancement may be one reason why photosynthesis is so remarkably effective at capturing solar energy. Similar quantum effects have been proposed for other biological processes. Some researchers suggest that bird navigation might involve quantum entanglement in specialized proteins in their eyes, allowing them to literally see magnetic fields. The sense of smell might depend on quantum tunneling, where molecules are recognized not just by their shape, but by their vibrational frequencies. Even the efficiency of enzyme reactions might be enhanced by quantum effects. These discoveries challenge our understanding of where quantum mechanics ends and classical biology begins. They suggest that life has evolved not just to tolerate quantum effects, but to exploit them. Rather than being destroyed by environmental decoherence, biological systems appear to have found ways to protect and utilize quantum coherence for functional advantages. The mechanisms by which biological systems maintain quantum coherence in noisy environments are still being investigated. Some researchers propose that proteins can create protected quantum spaces, shielding delicate quantum states from environmental disturbance. Others suggest that biological systems might use environmental noise constructively, harnessing decoherence processes to enhance rather than destroy quantum effects. These findings have profound implications for our understanding of life itself. They suggest that the boundary between the quantum and classical worlds is more fluid than previously imagined. Life exists at the edge of this boundary, utilizing quantum effects when advantageous while maintaining classical stability when necessary. The study of quantum biology is also inspiring new technologies. Scientists are developing artificial photosynthetic systems that mimic the quantum efficiency of natural photosynthesis. Quantum sensors based on biological principles might achieve unprecedented sensitivity. Understanding how life maintains quantum coherence could lead to new approaches for quantum computing and quantum communication. As you reflect on these biological quantum effects, consider how they might relate to your own experience of aliveness. While we don't yet understand whether consciousness itself involves quantum processes, there's something remarkable about how life seems to dance at the boundary between order and chaos, between coherence and decoherence. Your thoughts and experiences emerge from the complex interplay of countless molecular processes, some of which may themselves depend on quantum effects. Decoherence theory doesn't just explain how quantum mechanics becomes classical physics. It fundamentally challenges our understanding of what it means for something to be real. In the traditional view, objects either exist in definite states or they don't. Reality was assumed to be objective, independent of observation or environment. But decoherence reveals a more subtle picture, where reality emerges through relationship and interaction. From the decoherence perspective, the properties we consider most fundamental position, momentum, energy are not intrinsic to objects, but arise through their interaction with environment. An electron doesn't simply have a definite position. Instead, it develops apparent positional definiteness through its entanglement with environmental systems that monitor spatial information. This relational view of reality has profound philosophical implications. It suggests that the universe is not made of things with fixed properties, but of relationships and interactions. Reality becomes a dynamic process rather than a static collection of objects. The classical world emerges not because quantum mechanics stops working, but because environmental relationships select and stabilize certain quantum states while allowing others to decohere into unobservability. The role of information in this process is particularly striking. Decoherence theory suggests that information, rather than matter or energy, might be the most fundamental aspect of reality. The universe doesn't just process matter and energy, it processes information, constantly extracting, storing, and redistributing knowledge about the states of quantum systems. Reality emerges through information processing. This information theoretic view of reality connects quantum mechanics to broader questions about consciousness, computation, and meaning. Some researchers propose that consciousness itself might be understood as an information processing phenomenon, though this remains highly speculative and unproven. The connection between quantum information and conscious information, if it exists at all, is not yet understood. The implications extend to our understanding of free will and determinism. In a classical universe, events unfold according to deterministic laws or random processes. But decoherence introduces a third possibility: emergence. Properties and behaviors emerge through environmental interaction in ways that are neither purely deterministic nor purely random. This emergent causation might provide new perspectives on long-standing philosophical problems. Decoherence also illuminates the relationship between observers and observed reality. Rather than requiring conscious observers to collapse wave functions, decoherence shows that the environment itself acts as a continuous observer. Reality is constantly being observed, measured, and constructed through environmental monitoring. Consciousness doesn't create reality, but it participates in the ongoing process of reality construction. These philosophical implications remain controversial and open to interpretation. Different scientists and philosophers draw different conclusions from decoherence theory. Some see it as supporting materialist views of reality, where consciousness emerges from complex physical processes. Others find it compatible with more idealistic interpretations, where information and relationship are fundamental. Still others view it as neutral with respect to traditional philosophical debates. What seems clear is that decoherence theory enriches our conceptual vocabulary for thinking about reality, consciousness, and the relationship between quantum and classical worlds. It provides new tools for exploring ancient questions about the nature of existence, knowledge, and experience. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. As you contemplate these philosophical dimensions, notice how they might relate to your own experience of reality. Your sense of being a coherent, continuous self emerges from countless neural processes, many of which remain below the threshold of consciousness. Like quantum decoherence, your personal reality seems to emerge through the complex interplay of different systems and processes. While this isn't quantum mechanics at work in your mind, there are intriguing parallels in how both quantum systems and consciousness seem to involve emergence, relationship, and information processing. The study of quantum decoherence continues to evolve, driven by both fundamental scientific curiosity and practical technological needs. Researchers are pushing the boundaries of what's possible in creating and maintaining quantum coherence, while also exploring the fundamental limits of how long quantum effects can persist in realistic environments. One of the most exciting frontiers involves the creation of increasingly large quantum superposition states. Recent experiments have succeeded in placing objects containing thousands or even millions of atoms in quantum superposition, pushing the boundary between quantum and classical worlds to unprecedented scales. These experiments help test the limits of quantum mechanics and explore whether there might be fundamental size limits beyond which quantum superposition becomes impossible. Scientists have achieved remarkable milestones in this area. Researchers have created quantum superposition states that persist for tens of minutes, far longer than previously thought possible. They've placed crystals weighing micrograms in superposition, demonstrating quantum effects in objects visible to the naked eye. Each breakthrough reveals new insights into the mechanisms of decoherence and the conditions necessary for maintaining quantum coherence. The development of new materials and techniques for controlling decoherence is advancing rapidly. Scientists are creating artificial atoms with custom-designed decoherence properties, developing new superconducting materials with reduced environmental coupling, and inventing novel methods for isolating quantum systems from their surroundings. These advances are not only enabling better quantum technologies, but also providing new tools for studying fundamental physics. Theoretical research is exploring even more exotic possibilities. Some scientists are investigating whether gravity itself might contribute to decoherence, causing quantum superpositions to collapse due to gravitational interactions with spacetime. Others are studying whether the expansion of the universe or the properties of dark energy might affect quantum coherence on cosmic scales. These investigations probe the deepest connections between quantum mechanics and cosmology. The intersection of decoherence research with artificial intelligence and machine learning is opening new avenues of investigation. Researchers are developing AI systems that can optimize quantum control protocols, design better decoherence-resistant quantum states, and predict the behavior of complex quantum systems in realistic environments. Machine learning is accelerating the pace of discovery in quantum science. Applications of decoherence research extend far beyond quantum computing. Scientists are developing quantum sensors that can detect gravitational waves, magnetic fields, and even dark matter with unprecedented sensitivity. Quantum communication systems promise perfectly secure information transmission. Quantum metrology might enable measurements of fundamental constants with revolutionary precision. The study of decoherence is also informing research into the foundations of quantum mechanics itself. Scientists are using decoherence experiments to test different interpretations of quantum theory, explore the relationship between quantum mechanics and general relativity, and investigate whether quantum mechanics might need modification at extremely large or small scales. Looking toward the future, researchers envision quantum technologies that could revolutionize computing, communication, sensing, and simulation. Quantum computers might solve problems in medicine, materials science, and fundamental physics that are beyond the reach of classical computers. Quantum sensors could detect dark matter, probe the structure of spacetime, and enable new forms of medical imaging, quantum communication networks might provide the foundation for a quantum internet connecting quantum computers worldwide. Perhaps most intriguingly, the study of decoherence is beginning to inform our understanding of complex systems more broadly. Researchers are exploring whether decoherence-like processes might occur in neural networks, financial markets, ecological systems, and other complex networks. While these systems don't exhibit quantum mechanics, they may share similar principles of emergence, information processing, and environmental interaction. As you consider these future possibilities, reflect on how they might transform not just technology, but our understanding of reality itself. We're learning to manipulate the quantum world with increasing precision, potentially gaining new tools for exploring the deepest questions about consciousness, reality, and the nature of existence. These aren't just technological advances, they're steps toward a deeper understanding of our place in the universe. While most decoherence research focuses on laboratory systems and quantum technologies, the implications of environmental monitoring and information spreading extend to the largest scales imaginable. The entire universe might be understood as a vast decoherence process, where quantum possibilities continuously crystallize into classical reality through environmental interaction. In the early universe, shortly after the Big Bang, quantum fluctuations in the primordial fields created tiny variations in density and temperature. These quantum fluctuations, amplified by cosmic inflation, eventually grew into the large-scale structure we observe today: galaxies, galaxy clusters, and the cosmic web of matter that spans billions of light years. This process represents decoherence on a cosmic scale. The quantum fluctuations that once existed in superposition became entangled with their expanding environment, causing their wave-like properties to decohere into the classical density variations that seeded structure formation. The universe we inhabit emerged from quantum possibility through environmental decoherence, just like the classical objects in your immediate surroundings. Some researchers propose that the cosmic microwave background radiation, the faint afterglow of the Big Bang that permeates all of space, might preserve information about primordial quantum decoherence processes. Subtle patterns in this radiation could reveal how quantum superpositions collapsed into classical structure in the early universe, providing a cosmic laboratory for studying decoherence on the largest possible scales. The expansion of space itself might play a role in cosmic decoherence. As the universe expands, quantum systems become increasingly isolated from each other, but they also become entangled with the expanding spacetime geometry. This cosmological entanglement might contribute to the decoherence of quantum states, helping to explain why the universe appears classical on large scales despite being governed by quantum mechanics at its foundation. Black holes present another fascinating arena for decoherence research. The extreme gravitational fields near black holes might affect quantum coherence in unprecedented ways. Some theoretical work suggests that the event horizons of black holes could act as natural decoherence boundaries, where quantum information becomes irretrievably entangled with the black hole's interior. These investigations connect decoherence theory to some of the deepest puzzles in theoretical physics. The study of cosmic decoherence also raises profound questions about the nature of time and causality. If the universe emerged from quantum superposition through decoherence, then the arrow of time itself might be understood as a consequence of information spreading and environmental entanglement. The irreversible nature of decoherence could provide a fundamental explanation for why time flows in one direction rather than another. Dark matter and dark energy, the mysterious components that dominate the universe's energy budget, might also be connected to decoherence processes. Some speculative theories propose that dark matter consists of particles that interact primarily through decoherence-like processes, while dark energy might arise from the quantum vacuum's response to cosmic decoherence. While these ideas remain highly theoretical, they illustrate how decoherence concepts are being applied to cosmology's biggest mysteries. Neutrinos, nearly massless particles that barely interact with ordinary matter, provide a unique window into cosmic decoherence. These particles can travel across the universe while maintaining quantum coherence, making them natural probes of spacetime structure and potential decoherence effects. Recent experiments have used neutrinos to test whether quantum gravity might induce fundamental decoherence, setting the strongest constraints yet on such effects. The possibility that consciousness itself might be connected to cosmic decoherence processes remains purely speculative and unproven. Some interpretations suggest that conscious observation might play a role in reality construction, but there is no scientific consensus on these ideas. Any connections between consciousness and cosmic decoherence are metaphorical at best, not established scientific facts. As you contemplate these cosmic scales, consider how decoherence connects the smallest and largest phenomena in the universe. The same principles that govern quantum states in laboratory experiments also shape the formation of galaxies and the emergence of cosmic structure. You are part of a universe that emerged from quantum possibility through environmental decoherence. Your very existence a consequence of this fundamental process. Take a moment to appreciate the extraordinary journey we've taken together through the landscape of quantum decoherence. From the strange superpositions of individual particles to the cosmic web of galaxies, from the delicate qubits of quantum computers to the efficient energy transfer in photosynthesis, we've seen how environmental monitoring transforms quantum possibility into classical reality. This process is happening everywhere, all the time. As you listen to these words, countless quantum systems around you are undergoing decoherence, their superpositions dissolving into definite states through environmental entanglement. The classical world you experience emerges continuously from this quantum foundation, reality constructing itself moment by moment through the fundamental process of environmental selection. The beauty of decoherence lies not just in its explanatory power, but in its revelation of the deep interconnectedness of all things. No quantum system exists in isolation. Every particle, every atom, every molecule is constantly interacting with its environment, sharing information, becoming entangled with the larger web of existence. Reality emerges through relationship, through the ongoing dance of interaction and information exchange that connects every part of the universe to every other part. This understanding transforms our perspective on existence itself. You are not separate from the quantum processes that surround you. You're part of them, woven into the fabric of reality through countless environmental interactions. Your thoughts, your experiences, your very sense of being alive emerge from the same fundamental processes that transform quantum possibility into classical certainty. The journey into quantum decoherence reveals that reality is far stranger, far more beautiful, and far more interconnected than our everyday experience suggests. We live in a universe where possibility crystallizes into actuality through environmental relationship, where information spreads through cosmic networks of entanglement, where the very foundations of existence emerge from the delicate dance between coherence and decoherence. As we conclude this exploration, remember that the wonder of decoherence extends beyond its scientific implications. It offers a new way of understanding your place in the cosmos, your connection to the quantum foundations of reality, and the ongoing process by which the universe constructs itself around you. Every moment, you're participating in the grand decoherence of cosmic possibility into personal experience, part of reality's continuous emergence from the quantum realm. Perhaps this understanding can bring a sense of peace to your contemplation of existence. You are not an isolated observer of a foreign universe, but an integral part of the very process by which reality comes into being. The quantum world isn't separate from your world. It is your world, viewed through the lens of environmental decoherence and information processing. You are quantum possibility becoming classical reality, moment by moment, breath by breath, thought by thought. And speaking of thoughts and the quantum realm, there's another fascinating frontier where these ideas converge. If you've enjoyed this journey into how quantum physics creates reality, you might find yourself drawn to exploring how your sleeping mind processes information in ways that mirror quantum mechanics. Our next exploration, Quantum Dreams, the Secret Code. Your brain uses to communicate with you reveals the surprising parallels between dream states and quantum superposition, and how your unconscious mind might be using quantum-like processes to construct the reality of your inner world. But our exploration has only just begun to reveal the full tapestry of how quantum decoherence shapes the world around you. As we venture deeper into this mystery, we encounter realms where the boundaries between the possible and the actual become even more fluid, where the very fabric of space-time itself might be subject to the same decoherence processes that transform your everyday experience. Einstein showed us that space and time are not separate entities but form a unified fabric called space-time. This fabric can bend, stretch, and ripple like the surface of a pond disturbed by falling stones. But recent theoretical investigations suggest something even more profound. Space-time itself might be subject to quantum decoherence at the most fundamental level. At the smallest scales imaginable, far below the size of atoms, space-time might not be the smooth continuum we experience, but rather a foaming quantum structure where the very concepts of position and time lose their classical meaning. In this realm, the geometry of space itself exists in superposition, simultaneously curved in multiple ways until environmental interactions select which geometric configuration becomes real. This idea challenges our most basic assumptions about the nature of reality. We tend to think of space as the stage upon which quantum dramas unfold. But cutting-edge research suggests that space itself is one of the actors, the 3 dimensions you move through, and the flow of time you experience might emerge from deeper quantum processes through mechanisms analogous to the decoherence we've been exploring. Imagine space-time as a vast orchestra where each point in space and moment in time is like a musician playing quantum notes. In the quantum realm, each musician might be playing multiple melodies simultaneously, creating a cacophony of overlapping possibilities. But as these quantum fluctuations interact with their environment, certain harmonies are selected and amplified, while others fade into silence. The classical space-time we experience emerges from this cosmic symphony through environmental selection. Some theoretical frameworks suggest that gravity itself arises from quantum entanglement between different regions of space-time. When these entangled regions undergo decoherence, the connections between them manifest as gravitational attraction. This perspective, would make gravity not a fundamental force, but an emergent phenomenon arising from quantum information processing in the fabric of reality itself. These ideas remain highly speculative, existing at the cutting edge of theoretical physics, where mathematics meets philosophy. Yet they point toward a profound possibility that everything we consider fundamental about reality, including space, time, and gravity, might emerge from quantum processes through mechanisms we're only beginning to understand. As you contemplate these possibilities, notice how they might shift your relationship with the space around you, the room you're in, the air you breathe. Even the space between your thoughts might be far more dynamic and mysterious than they appear. While these remain theoretical speculations, they invite a sense of wonder about the hidden depths beneath the surface of ordinary experience. Deep beneath your feet, as you listen to these words, trillions of ghostly particles are streaming through your body without leaving the slightest trace. These particles, called neutrinos, are among the most abundant in the universe, yet they barely interact with ordinary matter. They pass through entire planets as if they were empty space, carrying with them precious information about the quantum processes that created them. Neutrinos present a unique window into cosmic scale decoherence because they can maintain quantum coherence across astronomical distances. While most particles lose their quantum properties quickly when exposed to environmental interactions, neutrinos are so weakly coupled to their surroundings that they can preserve delicate quantum superpositions for billions of years as they travel across the universe. Recent experiments have used this remarkable property to probe whether spacetime itself might induce fundamental decoherence. If quantum gravity effects cause the fabric of reality to fluctuate at the smallest scales, these fluctuations might gradually destroy even the most robust quantum coherences. Neutrinos, with their ability to maintain coherence across cosmic distances, provide the perfect test particles for detecting such effects. The results have been both fascinating and reassuring. No evidence of neutrino decoherence has been detected, setting the strongest constraints ever achieved on quantum gravity theories that predict fundamental decoherence. This suggests that quantum mechanics remains valid even under the most extreme conditions, preserving its coherence across the vast expanses of space and time that separate us from distant galaxies. These experiments reveal something profound about the nature of information in the universe. Quantum information, once created, can persist across cosmological scales, carrying messages from the most violent events in cosmic history. When you detect a neutrino that was created in the core of the Sun, you're receiving quantum information that has maintained its coherence for the 8 minutes it took to travel from the solar interior to your location. The study of neutrino coherence also illuminates the relationship between quantum mechanics and relativity. These particles travel at nearly the speed of light across distances where space itself is expanding. Yet they maintain quantum properties that depend on precise phase relationships. This persistence of quantum coherence in an expanding universe provides crucial insights into how quantum mechanics operates on cosmic scales. Consider how these cosmic messengers connect you to the broader universe. Every second, billions of neutrinos from the Sun pass through your body, along with neutrinos created in distant stars, supernovae, and even the Big Bang itself. You are constantly bathed in quantum information from across the cosmos, participating in a vast network of quantum coherence that spans space and time. This cosmic perspective on quantum coherence invites a sense of connection to processes far beyond your immediate experience. While you cannot feel these neutrinos passing through you, their presence represents a tangible link to the quantum processes that power stars, create elements, and drive the evolution of galaxies. You are part of a universe where quantum information flows freely across impossible distances, connecting every part of reality to every other part through networks of preserved coherence. One of the most profound mysteries in physics is the arrow of time. Why does time flow in one direction rather than another? Why do we remember the past but not the future? Why does entropy increase, causing systems to become more disordered over time? The answer, according to recent research, may lie in the irreversible nature of quantum decoherence. At the fundamental level, the laws of physics are time-symmetric. The equations that govern quantum mechanics work equally well, whether time flows forward or backward. Yet our experience of time has a clear direction. We age, we remember, we anticipate. Effects follow causes, not the other way around. This asymmetry in our experience of time must arise from something beyond the fundamental laws themselves. Decoherence provides a compelling explanation for the arrow of time. When quantum information spreads into the environment through decoherence, it becomes practically irretrievable. This irreversible loss of information creates a fundamental asymmetry between past and future. The past is the direction in which information was lost. The future is the direction in which information continues to be lost. Think of decoherence as creating a cosmic archive of everything that has happened. Every quantum measurement, every environmental interaction, every moment of decoherence leaves an indelible record in the vast library of environmental states. The past exists as information that has been written into this cosmic memory. The future exists as information yet to be written. This perspective suggests that memory itself, whether in your brain or in physical systems, is fundamentally connected to decoherence processes. When you form a memory, you're creating a record of information that has undergone irreversible environmental interaction. The neural patterns that encode your memories are stable precisely because they've reached states that are robust against further decoherence. The thermodynamic arrow of time, the tendency for entropy to increase, emerges naturally from decoherence processes. As quantum systems become entangled with their environments, the total number of possible configurations increases exponentially. This proliferation of possibilities manifests as increasing entropy, the famous second law of thermodynamics that governs everything from melting ice to aging organisms. Recent theoretical work has explored how decoherence might create multiple arrows of time in different regions of the universe. If the cosmos contains isolated regions where decoherence proceeds in different directions, these regions might experience time flowing in opposite directions. While this remains highly speculative, it illustrates how intimately connected decoherence is to our most basic experience of temporal flow. The psychological arrow of time, your subjective experience of temporal flow, might also be connected to decoherence processes in your brain. While consciousness remains far from understood, some researchers speculate that the irreversible nature of neural information processing creates the sense that time moves from past to future. This remains an unproven hypothesis, but it suggests intriguing connections between quantum decoherence and conscious experience. As you reflect on your own experience of time, notice how it seems to flow inevitably from past through present toward future. This flow might not be an illusion, but rather a fundamental feature of reality, arising from the irreversible spread of quantum information through environmental decoherence. Your memories, your anticipations, your sense of temporal progression all participates in the cosmic process by which information moves irreversibly from coherent possibility into decoherent actuality. Decoherence reveals something remarkable about the relationship between simplicity and complexity in nature. While the fundamental rules of quantum mechanics are relatively straightforward, their interaction with environmental systems creates phenomena of stunning richness and complexity. This emergence of complexity from simple rules appears throughout nature, from the formation of galaxies to the development of consciousness. The process begins with quantum superposition, where systems exist in multiple states simultaneously. When these systems interact with their environments, decoherence selects certain states while suppressing others. But this selection process isn't random. It follows patterns determined by the specific ways systems couple to their environments, creating structured pathways from quantum possibility to classical actuality. Consider how this process operates in the formation of matter itself. In the early universe, quantum fluctuations existed in superposition, representing countless possible distributions of energy and matter. As the universe expanded and cooled, environmental interactions began selecting certain patterns while allowing others to decohere. The large-scale structure of the cosmos, with its galaxies, galaxy clusters, and vast cosmic voids, emerged from this selective decoherence of primordial quantum possibilities. The same principles operate at smaller scales. When atoms combine to form molecules, quantum decoherence helps select which molecular configurations are stable and which are not. The chemical properties that give rise to life, consciousness, and technology emerge from quantum selection processes that favour certain arrangements of matter over others. In biological systems, decoherence processes might help explain how complex structures and functions emerge from relatively simple components. The efficiency of photosynthesis, the precision of enzyme reactions, and even the development of neural networks might all benefit from quantum selection processes that favour functional over dysfunctional configurations. This emergence of complexity through decoherence suggests a deep principle. The universe has an inherent tendency to create order from chaos, structure from randomness, meaning from noise. Environmental decoherence acts as a natural filter, preserving configurations that are robust and stable, while eliminating those that are fragile and unstable. The implications extend to human creativity and cultural evolution. While these processes don't involve quantum mechanics directly, they share similar principles of variation and selection. Ideas, artistic expressions, and social innovations emerge from the interaction between individual creativity and environmental feedback. The cultural patterns that persist are those that prove robust against the decoherence of changing social conditions. Understanding emergence through decoherence also illuminates the relationship between reductionism and holism in science. While complex systems are built from simple components following simple rules, the emergent properties that arise from environmental selection cannot be predicted from knowledge of the components alone. Decoherence creates genuine novelty, producing effects that are more than the sum of their parts. This principle suggests that consciousness itself, while not necessarily involving quantum mechanics, might emerge through similar processes of environmental selection operating on neural activity. The patterns of thought and experience that constitute your conscious awareness might arise from the brain's natural tendency to preserve coherent, stable patterns, while allowing incoherent, unstable patterns to fade away. As you contemplate your own complexity as a conscious being, consider how you might represent an emergent phenomenon arising from countless simpler processes. Your thoughts, emotions, memories, and sense of identity emerge from the interactions of neurons, which themselves emerge from the interactions of molecules, which emerge from the interactions of atoms, which emerge from quantum processes subject to environmental decoherence. You are complexity built upon simplicity, order arising from the fundamental chaos of quantum possibility. While much of our discussion has focused on how decoherence transforms quantum strangeness into classical reality, researchers are also learning to harness decoherence processes for practical applications. Rather than always fighting against environmental interaction, scientists are discovering ways to use decoherence constructively, turning what was once considered a limitation into a resource for new technologies. One promising area involves quantum sensors that use carefully controlled decoherence to achieve unprecedented sensitivity. By allowing quantum systems to interact with their environments in precisely controlled ways, researchers can amplify tiny signals that would otherwise be undetectable. These sensors might revolutionize medical imaging, geological surveying, and fundamental physics research. Decoherence-enhanced computing represents another frontier. While quantum computers typically require the suppression of environmental interaction, some algorithms actually benefit from controlled decoherence. These hybrid classical quantum systems use environmental noise constructively, achieving computational advantages that neither purely classical nor purely quantum systems can match. The field of quantum metrology is developing techniques that use decoherence to measure fundamental constants with extraordinary precision. By studying how environmental interactions affect quantum systems, scientists can extract information about gravitational fields, electromagnetic properties, and even the structure of spacetime itself, with sensitivity approaching theoretical limits. Biological applications of decoherence research are emerging in medicine and biotechnology. Understanding how living systems maintain quantum coherence in noisy environments is inspiring new approaches to drug design, medical imaging, and therapeutic intervention. Artificial photosynthetic systems based on quantum coherence principles might provide new sources of clean energy. Communication technologies are also being transformed by decoherence research. Quantum communication systems that use environmental monitoring for security are being developed. These systems detect eavesdropping attempts by monitoring changes in decoherence patterns, providing unprecedented levels of information security. The development of new materials with custom decoherence properties is opening possibilities we're only beginning to explore. Scientists are creating artificial atoms, engineered molecules, and nanostructures with precisely controlled environmental coupling. These materials might enable room temperature quantum computing, ultra-sensitive detectors, and entirely new forms of information processing. Machine learning techniques are accelerating progress in all these areas. AI systems are being trained to optimize quantum control protocols, predict decoherence behavior, and design new quantum technologies. The intersection of artificial intelligence and quantum decoherence research is creating a positive feedback loop that accelerates discovery and development. Perhaps most intriguingly, some researchers are exploring whether decoherence principles might apply to information processing in general, including artificial intelligence and neural networks. While these systems don't exhibit quantum mechanics, they might benefit from similar principles of environmental selection and emergent complexity. Looking toward the future, we can envision technologies that seamlessly integrate quantum and classical information processing, using decoherence as a bridge between these realms. Such systems might achieve computational capabilities that surpass both classical and quantum computers by harnessing the best features of each approach. The practical applications of decoherence research remind us that scientific understanding often leads to technological transformation. The abstract principles we've been exploring are not merely intellectual curiosities, but foundations for technologies that might reshape human civilization. From quantum sensors that can detect dark matter to communication networks that provide perfect security, decoherence research is opening doorways to possibilities we're only beginning to imagine. As you consider these technological horizons, reflect on how scientific understanding continuously transforms human experience. The quantum decoherence processes we've been exploring might soon enable technologies that change how you communicate, compute, sense your environment, and understand your place in the cosmos. The boundary between fundamental science and practical application is itself subject to a kind of decoherence, where abstract possibilities crystallize into concrete realities that transform the world. One of the most remarkable aspects of decoherence is how it operates across an extraordinary range of scales. From the quantum foam that might exist at the smallest conceivable distances to the vast cosmic web that spans billions of light years. This universality suggests that decoherence represents a fundamental organizing principle of reality, shaping structure and behavior at every level of existence. At the Planck scale, distances so small that they approach the limits of meaningful measurement, spacetime itself might undergo constant decoherence. Quantum fluctuations in the geometry of space could create and destroy virtual black holes, wormholes, and other exotic structures in a continuous dance of possibility and actuality. While we cannot observe these processes directly, their effects might propagate upward through the scales, influencing everything from particle interactions to cosmological evolution. Moving up in scale, atomic and molecular decoherence creates the stable chemical properties that make complex matter possible. The electron orbitals that define atomic behavior, the molecular bonds that hold compounds together, and the crystalline structures that give materials their properties all emerge from quantum selection processes that favor certain configurations over others. At the scale of living cells, decoherence might play crucial roles in biological function. The efficiency of enzyme reactions, the fidelity of DNA replication, and the sensitivity of sensory systems might all depend on quantum coherence effects that persist just long enough to provide functional advantages before succumbing to environmental decoherence. Scaling up to organisms and ecosystems, while decoherence no longer operates directly, similar principles of environmental selection and information processing continue to shape complex systems. The evolution of species, the dynamics of ecosystems, and even the development of consciousness might follow patterns analogous to quantum decoherence, where environmental feedback selects for stable, functional configurations. At planetary scales, the Earth's climate system, magnetic field, and geological processes operate through complex feedback mechanisms that share conceptual similarities with decoherence. Information about changing conditions spreads through environmental systems, driving evolution toward new equilibrium states through processes that are irreversible on human timescales. Moving to stellar and galactic scales, the formation of stars, the evolution of galaxies, and the creation of heavy elements through stellar nucleosynthesis all involve processes where quantum mechanics operating at small scales influences structure and behavior at cosmic scales. The decoherence of primordial quantum fluctuations continues to shape the large-scale structure of the universe billions of years after the Big Bang. At the largest observable scales, the cosmic microwave background radiation preserves information about quantum decoherence processes that occurred when the universe was less than 400,000 years old. These ancient light patterns reveal how quantum superpositions collapsed into the classical density variations that eventually grew into galaxies and galaxy clusters. This hierarchy of scales reveals something profound about the nature of reality. The same fundamental principles that govern quantum decoherence at microscopic scales also shape emergent phenomena at every level of organization. Reality appears to be structured as nested layers of emergence, where each level arises from the environmental selection of stable patterns at the level below. The interconnectedness implied by this scale-spanning influence of decoherence suggests that you are intimately connected to processes operating at every scale of existence. The quantum decoherence occurring in your brain cells connects you to the molecular processes that enable life, which connect you to the stellar nucleosynthesis that created the elements in your body, which connects you to the cosmic decoherence that shaped the large-scale structure of the universe. This perspective invites a sense of participation in the cosmic process of reality construction. Every thought, every breath, every moment of conscious experience represents a continuation of the same fundamental process that transformed the quantum possibilities of the early universe into the rich, complex, interconnected reality you experience today. Take a moment to feel this connection across scales, from the quantum processes in your neurons to the cosmic web that spans the observable universe. You are part of a single, integrated system where information flows, patterns emerge, and reality continuously constructs itself through the universal principles of environmental selection and quantum decoherence. Throughout our exploration of quantum decoherence, we've repeatedly encountered the central role of information in shaping physical reality. This isn't merely a metaphor or philosophical speculation. Cutting-edge research in physics increasingly suggests that information might be more fundamental than matter, energy, space, or time. Decoherence processes are, at their core, information processing phenomena that determine which possibilities become real and which remain forever unrealized. When a quantum system becomes entangled with its environment through decoherence, what actually spreads through the surroundings is information about the system state. This information doesn't just describe reality. In a very real sense, it creates reality by establishing which quantum possibilities will be preserved and which will become unobservable. This information-theoretic view of reality has profound implications. If information is truly fundamental, then the universe might be understood as a vast computational process, continuously processing information about its own quantum states through environmental decoherence. Reality emerges from this cosmic computation, with consciousness, matter, energy, and spacetime all arising as emergent phenomena from underlying information processing. Consider how this perspective might illuminate your own existence. Your thoughts, memories, and conscious experiences are patterns of information encoded in neural networks. These patterns persist and evolve through processes that share deep similarities with quantum decoherence. Information about your experiences spreads through neural networks, becoming integrated into larger patterns that constitute your sense of identity and understanding. The information processing view also suggests new approaches to understanding consciousness itself. While we cannot yet determine whether consciousness involves quantum processes directly, it clearly involves sophisticated information processing that shares many characteristics with quantum decoherence. The integration of multiple information streams, the selection of certain patterns over others, and the emergence of coherent structures from complex noisy environments. Some researchers speculate that consciousness might represent a form of classical decoherence, where the brain's information processing systems naturally select coherent, stable patterns of neural activity while allowing incoherent, unstable patterns to fade away. This remains highly speculative and unproven, but it illustrates how decoherence principles might extend beyond quantum mechanics to illuminate other complex systems. The primacy of information also connects quantum decoherence to questions about the nature of mathematics, logic, and meaning itself. If reality emerges from information processing, then the mathematical structures that describe physical laws might be more than mere human constructions. They might represent fundamental features of the cosmic information processing system that generates reality through quantum decoherence. This perspective invites a profound shift in how we understand our relationship to the universe. Rather than being isolated observers of a foreign reality, we might be understood as integral components of the cosmic information processing system. Our thoughts, discoveries, and understanding contribute to the ongoing process by which the universe processes information about itself. The information theoretic view also illuminates the deep connections between physics, computation, and consciousness. All three involve the processing of information according to systematic rules, the emergence of complex patterns from simpler components, and the selection of certain possibilities over others through environmental feedback. While much of this remains speculative and unproven, the information processing perspective on decoherence opens new avenues for understanding the deepest questions about reality, consciousness, and existence. It suggests that information might be the common thread that connects quantum mechanics, classical physics, biology, and consciousness into a unified understanding of reality. As you contemplate these ideas, notice how your own thinking represents a form of information processing. The concepts we've been exploring spread through your neural networks, becoming integrated with your existing knowledge and understanding. Your comprehension of quantum decoherence is itself a kind of decoherence process, where abstract possibilities crystallize into concrete understanding through the information processing dynamics of consciousness. This recursive quality, where consciousness contemplates the information processing basis of reality, reveals something profound about the nature of understanding itself. We are information processing systems, studying information processing systems, patterns of information, seeking to understand the patterns from which they emerge. In this sense, your exploration of quantum decoherence represents a continuation of the cosmic process of reality construction through information processing and environmental selection. As our journey through the landscape of quantum decoherence nears its contemplative conclusion, we encounter perhaps the most intriguing question of all. What does decoherence tell us about the nature of consciousness and our place in the cosmic order? While we must be careful not to overstate the connections, there are striking parallels between how quantum systems transition from superposition to classical reality, and how conscious awareness emerges from the complex dynamics of neural activity. Your conscious experience, like quantum decoherence, involves the continuous selection of certain patterns from a vast space of possibilities. At any given moment, your brain processes enormous amounts of information from sensory input, memory, and internal neural activity. Yet you experience a coherent, unified stream of consciousness rather than a chaotic jumble of competing signals. This coherence emerges through processes that bear fascinating resemblances to environmental selection in quantum systems. Consider how attention functions in your mental life. When you focus on these words, countless other sensory inputs, thoughts, and mental processes fade into the background. This selective attention operates like environmental decoherence, preserving certain patterns of neural activity while allowing others to become unobservable. The thoughts that persist are those that prove robust against the background noise of competing mental processes. Memory formation and retrieval also exhibit decoherence-like properties. When you form a new memory, neural patterns encoding that information must achieve a kind of stability that allows them to persist over time. Memories that lack this stability fade away, while those that achieve robust encoding can be retrieved years or decades later. This selective preservation of information mirrors how environmental decoherence preserves certain quantum states while allowing others to disappear. The relationship between conscious and unconscious mental processes further parallels quantum superposition and classical measurement. Much of your mental activity occurs below the threshold of consciousness, existing in a kind of cognitive superposition where multiple possibilities coexist simultaneously. When certain patterns reach consciousness, they undergo something analogous to measurement, crystallizing from vague possibilities into definite thoughts and experiences. These parallels remain metaphorical rather than literal. There is currently no scientific evidence that consciousness directly involves quantum mechanics, and we must be careful not to conflate similarity with identity. Yet the structural similarities between decoherence and consciousness suggest that certain organizational principles might operate across different levels of reality, from quantum systems to neural networks. Some interpretations suggest that consciousness might represent an emergent form of information processing that shares deep principles with quantum decoherence, even if it doesn't directly involve quantum mechanics. Both involve the continuous selection of stable patterns from complex dynamic systems through environmental feedback. Both create coherent structures from noisy, chaotic backgrounds through processes that are irreversible and information preserving. The contemplation of these connections invites a profound shift in perspective. Rather than seeing consciousness as separate from the physical processes that govern reality, we might understand it as a continuation of the same fundamental processes that shape reality at every scale. You might be understood as a localized pattern of information processing, arising from the same cosmic principles that transform quantum possibility into classical actuality. The emergence of consciousness from neural complexity mirrors how classical properties emerge from quantum decoherence. Just as environmental monitoring selects certain quantum states while suppressing others, the brain's information processing networks select certain patterns of neural activity while allowing others to fade away. Your sense of unified conscious experience might arise through mechanisms analogous to ion selection, where environmental feedback naturally preserves coherent, stable patterns while eliminating incoherent, unstable ones. This perspective, while remaining entirely metaphorical and unproven, offers a new way of understanding your place in the cosmic order. Rather than being an isolated observer of quantum processes, you might be understood as a natural continuation of them. The same principles that govern the transition from quantum possibility to classical reality might operate in transformed ways in the emergence of consciousness from neural activity. Take a moment to consider this possibility. As you listen to these words, neural patterns in your brain are processing information, integrating new concepts with existing understanding, and creating coherent patterns of meaning from the complex dynamics of thought. This information processing shares structural similarities with the environmental selection processes that shape quantum decoherence, even though the mechanisms are entirely different. The contemplation of these connections invites a profound sense of continuity between mind and cosmos. Your thoughts and experiences might represent a natural flowering of the same information processing principles that govern quantum systems, molecular interactions, and cosmic evolution. While consciousness remains mysterious and quantum mechanics strange, both participate in the ongoing cosmic process of reality construction through information selection and environmental interaction. As we approach the gentle conclusion of our exploration, it's important to recognize that quantum decoherence isn't a process that happened once in the distant past or that occurs only in specialized laboratory conditions. It's happening right now, everywhere around you, in an eternal dance of possibility and actuality that never stops, never rests, never reaches a final state of completion. Every photon of light that touches your skin carries information about your body's temperature and position into the surrounding environment. Every molecule of air that you breathe becomes entangled with your respiratory system, spreading quantum information about your biological processes into the atmosphere. Every neural firing in your brain involves quantum processes that undergo decoherence as they interact with the complex biochemical environment of your nervous system. This continuous, omnipresent decoherence means that reality is not a static structure, but a dynamic process of constant becoming. The classical world you experience is continuously emerging from quantum foundations through environmental selection. Every moment represents a fresh crystallization of quantum possibility into classical actuality through the ongoing dance of decoherence. The irreversible nature of this process creates what we might call the cosmic arrow of becoming. Each moment of decoherence adds new information to the vast environmental library of what has occurred. The past grows continuously richer as more quantum possibilities collapse into classical realities, while the future remains open to new possibilities that have not yet undergone environmental selection. This perspective transforms our understanding of time and change. Rather than moving through a pre-existing temporal landscape, we might be understood as participating in the continuous construction of that landscape through decoherence processes. Time doesn't just pass, it accumulates layer by layer as each moment's quantum possibilities are resolved into classical realities through environmental interaction. The eternal nature of decoherence also means that the boundary between quantum and classical worlds is not fixed but constantly shifting. At every scale and in every system, quantum coherence is being created and destroyed through environmental interaction. The classical world emerges continuously from quantum foundations, while quantum effects continuously arise from the complex dynamics of classical systems. Consider how this eternal process connects you to the deepest rhythms of cosmic evolution. Every breath you take, every thought you think, every moment of conscious experience represents a participation in the ongoing process by which the universe constructs reality from quantum possibility. You are not separate from this cosmic process, but an integral part of it, a localized pattern in the eternal dance of decoherence and emergence. The beauty of this eternal dance lies in its combination of pattern and novelty, structure and surprise. While decoherence follows consistent principles, it never produces exactly the same outcome twice. Each moment brings genuinely new information into existence, adding to the cosmic library of what has occurred while opening new possibilities for what might occur next. This understanding invites a profound appreciation for the present moment. Right now, as you listen to these words, quantum possibilities are crystallizing into classical realities through environmental decoherence. Information about this very moment is spreading into the environment, becoming part of the irreversible record of what has occurred. You are witnessing and participating in the continuous birth of reality from quantum possibility. The eternal nature of decoherence also suggests that wonder and mystery are not temporary features of our current understanding, but permanent aspects of existence itself. No matter how much we learn about quantum mechanics and decoherence, the process itself will continue to generate new phenomena, new questions, and new opportunities for discovery. The universe will always be stranger and more beautiful than our current understanding can encompass. As we contemplate this eternal dance, notice how it might transform your relationship with change and uncertainty in your own life. Just as quantum systems cannot predict exactly which states will emerge from decoherence, you cannot know exactly what will emerge from the complex environmental interactions that shape your experience. Yet this uncertainty is not a limitation, but a source of genuine novelty and possibility. The eternal dance of decoherence reminds us that reality is not a problem to be solved, but a mystery to be lived. Each moment brings new possibilities into existence while preserving the accumulated wisdom of all previous moments. You are part of this cosmic process of continuous becoming, contributing your own unique patterns to the eternal dance of quantum possibility and classical actuality. As our gentle journey through the landscape of quantum decoherence draws toward its natural conclusion, it's worth reflecting on what this understanding offers to human experience. Beyond its scientific importance, beyond its technological applications, decoherence provides a new lens through which to view existence, relationship, and meaning itself. First, decoherence offers a profound lesson in interconnectedness. The central insight that no quantum system exists in isolation, that all reality emerges through environmental interaction, provides a scientific foundation for understanding how deeply connected everything truly is. You are not a separate entity observing a foreign universe, but an integral part of the cosmic web of interaction and information exchange that creates reality itself. This interconnectedness extends beyond the physical realm into the domains of meaning and understanding. Your thoughts and experiences don't exist in isolation, but emerge through constant interaction with your social, cultural, and intellectual environment. Like quantum decoherence, consciousness appears to be fundamentally relational, arising through the ongoing dance of interaction between inner patterns and outer influences. Second, decoherence provides a new perspective on the relationship between order and chaos, structure and randomness. Rather than seeing these as opposing forces, decoherence reveals them as collaborative partners in the creation of reality. Environmental noise and quantum uncertainty don't destroy order. They participate in creating it through selective processes that preserve functional patterns while eliminating dysfunctional ones. This insight can transform how you relate to uncertainty and change in your own life. Rather than viewing challenges and disruptions as purely destructive forces, you might see them as environmental interactions that help select and strengthen the most robust aspects of your character, understanding, and relationships. Like quantum decoherence, personal growth often involves the dissolution of unstable patterns to make room for more coherent, resilient ones. Third, decoherence illuminates the active role of environment in shaping reality. The classical world doesn't emerge despite environmental interaction, but because of it. This perspective can transform how you understand your own development and the development of human culture. Your thoughts, values, and capabilities are not fixed properties but emerge through ongoing interaction with your intellectual, social, and cultural environment. Understanding the active role of environment also highlights the responsibility we bear for shaping the conditions in which consciousness and culture develop. Just as carefully controlled environments enable quantum coherence to persist longer, thoughtfully structured social and educational environments can help human potential flourish more fully. Fourth, decoherence offers a new understanding of information and its fundamental role in reality. The recognition that information might be more basic than matter or energy provides a framework for understanding how knowledge, meaning, and consciousness relate to the physical world. Your thoughts and experiences are not separate from physical reality, but represent sophisticated forms of information processing that emerge from the same principles that govern quantum systems. This information theoretic perspective can transform how you understand the value of knowledge, art, and culture. These are not mere human constructions, but sophisticated patterns of information processing that participate in the ongoing cosmic process of reality construction through environmental selection and feedback. Fifth, decoherence provides a scientific foundation for appreciating mystery and wonder. Rather than explaining away the strangeness of existence, decoherence reveals new depths of mystery at every level of reality. The more we understand about how classical reality emerges from quantum foundations, the more remarkable the whole process appears. This perspective can foster a sense of appropriate humility and awe in the face of existence itself. The fact that you can contemplate these ideas, that consciousness can emerge from quantum processes through environmental decoherence, that the universe can become aware of itself through beings like yourself, remains profoundly mysterious and beautiful. Finally, decoherence offers a new framework for understanding the relationship between science and spirituality. Rather than being opposed domains, both involve the exploration of how consciousness relates to the deeper patterns that govern reality. While science explores these patterns through measurement and mathematics, spiritual traditions explore them through contemplation and direct experience. The understanding that reality emerges through relationship and interaction provides common ground between scientific and contemplative approaches to existence. Both recognize that isolation is illusory, that meaning emerges through connection, and that the deepest truths about reality cannot be grasped through purely analytical approaches. As you integrate these insights into your own understanding, notice how they might transform your relationship with everyday experience. The coffee cup beside you, the air you breathe, the thoughts moving through your mind, all participate in the cosmic dance of quantum decoherence and environmental selection. You're surrounded by and composed of mystery, even in the most ordinary moments. The gift of understanding quantum decoherence is not just intellectual knowledge, but a transformed appreciation for the profound depth and beauty that underlies all experience. This understanding invites a sense of participation in something much larger than individual existence, while simultaneously revealing the irreplaceable uniqueness of your particular perspective on the cosmic process. Take a moment to appreciate this gift. Through the patient work of countless scientists, through the development of sophisticated technologies, through the gradual accumulation of human understanding, we have gained insight into one of the most fundamental processes in nature. This knowledge is not separate from you, but becomes part of you, transforming how you see and relate to the world around you. In this transformation of understanding, you participate in the ongoing evolution of human consciousness itself. Each person who grasps these ideas contributes to the collective human appreciation for the remarkable nature of existence. Like quantum decoherence spreading information through environmental networks, understanding spreads through cultural networks, gradually transforming how our species relates to reality itself. And so we arrive at the soft conclusion of our journey through the realm where quantum physics transforms into the reality you experience every moment of your existence. We've travelled together through landscapes of possibility and actuality, through the delicate boundaries where superposition gives way to definiteness, where the strange becomes familiar, through the elegant process of environmental decoherence. Throughout this exploration, we've discovered that decoherence is not merely a technical detail of quantum mechanics, but a fundamental principle that shapes reality at every scale. From the quantum foam that might exist at the smallest distances to the cosmic web that spans the observable universe. From the efficiency of photosynthesis to the formation of your thoughts and memories, the same basic process operates. Environmental interaction selects certain patterns while allowing others to fade into unobservability. This understanding transforms our relationship with existence itself. You are not an isolated observer of a foreign universe, but an integral participant in the ongoing process of reality construction. Every breath you take, every thought you think, every moment of conscious awareness represents a continuation of the cosmic dance between possibility and actuality that began with the Big Bang and continues in every quantum interaction throughout the universe. The irreversible nature of decoherence creates the arrow of time that gives structure to your experience, while the selective nature of environmental interaction explains why the world appears classical and definite rather than quantum and probabilistic. Reality emerges continuously from quantum foundations through processes so subtle and rapid that they remain completely invisible to direct perception. Yet their effects shape every aspect of the world you inhabit. We've seen how this understanding illuminates everything from the development of quantum technologies to the emergence of biological complexity, from the formation of cosmic structure to the nature of consciousness itself. While many connections remain speculative and unproven, the patterns suggest deep principles that operate across different levels of reality, connecting quantum mechanics to chemistry, biology, psychology, and even contemplative experience. The practical implications of decoherence research are revolutionizing technology, from quantum computers that might solve previously intractable problems to sensors that could detect dark matter and gravitational waves. Yet perhaps more importantly, understanding decoherence provides a new framework for appreciating the profound mystery and beauty of existence itself. In contemplating quantum decoherence, we discover that reality is far stranger, far more interconnected, and far more wonderful than our everyday experience suggests. The classical world that feels so solid and dependable emerges from quantum foundations through processes that seem almost magical in their elegance and efficiency. Yet this magic operates according to precise mathematical principles that we can study, understand, and even harness for human benefit. The information-theoretic nature of decoherence suggests that knowledge and understanding are not mere human constructions, but fundamental features of reality itself. The universe appears to be engaged in continuous information processing, constantly extracting, storing, and redistributing knowledge about its own quantum states through environmental decoherence. Your thoughts and experiences participate in this cosmic information processing, contributing your unique perspective to the ongoing process of reality construction. This perspective invites a profound sense of connection to the deepest processes of cosmic evolution. The elements in your body were forged in stellar cores through quantum processes subject to decoherence. The oxygen you breathe was created through photosynthesis that may depend on quantum coherence effects. The neural patterns that generate your thoughts emerge from quantum processes in your brain that undergo constant environmental decoherence. You are not separate from the quantum world, but a natural expression of it, a localized pattern of information, processing arising from the same principles that govern the transition from quantum possibility to classical actuality throughout the universe. This understanding doesn't diminish the mystery of consciousness, but deepens it, revealing new dimensions of wonder in the relationship between mind and cosmos. As you continue to contemplate these ideas, remember that understanding quantum decoherence is not just an intellectual exercise, but a transformation of awareness itself. These insights become part of your mental landscape, influencing how you perceive relationships, change, uncertainty, and meaning in your daily life. The knowledge spreads through your cognitive networks, like information spreading through environmental systems during decoherence, gradually transforming your understanding of what it means to exist. The journey we've shared represents just the beginning of what may be a lifetime of deepening appreciation for the quantum foundations of reality. Each new discovery in decoherence research reveals additional layers of mystery and beauty in the process by which the universe constructs itself. The questions we have explored tonight will continue to evolve as human understanding grows, opening new vistas of wonder and possibility. In the end, quantum decoherence teaches us that reality is not a fixed structure, but a dynamic process of continuous becoming. Every moment brings new quantum possibilities into classical actuality through environmental interaction. The universe is not winding down toward a static final state, but continuously creating new information, new patterns, new possibilities for complexity and beauty. You are part of this cosmic creativity, a unique expression of the universe's capacity to know and appreciate itself. Your consciousness represents billions of years of cosmic evolution, culminating in patterns of neural activity sophisticated enough to contemplate the quantum processes from which they emerge. In understanding decoherence, You participate in the universe's growing awareness of its own deepest principles. Take a gentle breath and feel yourself settling into this understanding. You are quantum possibility becoming classical reality, moment by moment, thought by thought, breath by breath. You are part of the eternal dance between order and chaos, structure and surprise, possibility and actuality that drives the ongoing evolution of cosmic complexity. The mysteries we have explored tonight will continue to unfold as you sleep, as you dream, as you wake to another day of conscious experience. The quantum processes that generate your thoughts and perceptions will continue their ancient dance, transforming possibility into experience through the elegant mechanisms of environmental decoherence. And perhaps in your dreams tonight, your mind will continue processing these ideas in ways that mirror the quantum superpositions we've been discussing. The boundary between waking and sleeping consciousness shares intriguing parallels with the boundary between quantum and classical reality, where multiple possibilities can coexist until observation or awareness selects one pathway into definite experience. If these explorations have stirred your curiosity about the hidden connections between quantum processes and conscious experience, you might find yourself drawn to another mysterious frontier where these realms intersect. In our next contemplation, Quantum Dreams, the Secret Code your brain uses to communicate with you, will explore how your sleeping mind might use quantum-like processes to weave meaning from the chaos of neural activity, creating the strange, symbolic narratives that visit you each night. It's a journey into the quantum landscape of consciousness itself, where the rules of logic dissolve and new forms of information processing emerge from the dreaming brain. But for now, rest in the wonder of what we've discovered together. You are part of something magnificent and mysterious, a universe that transforms quantum strangeness into classical beauty through the gentle, persistent process of environmental decoherence. In understanding this process, you've gained not just knowledge, but a new way of being in relationship with the cosmos itself. Sleep well and dream of quantum possibilities becoming real. As we drift deeper into this contemplation of quantum decoherence, we encounter something profound and humbling. The recognition that our understanding, however elegant and far-reaching, remains fundamentally incomplete. There are horizons beyond which even our most sophisticated theories cannot yet peer, mysteries that decoherence illuminates while simultaneously revealing new depths of unknowing. Consider the measurement problem that still puzzles physicists today. While decoherence explains how quantum superpositions become effectively classical through environmental interaction, it doesn't fully explain why we observe one specific outcome rather than another when a measurement occurs. The theory beautifully describes the transition from many possibilities to one definite result, but the selection of which particular result manifests remains shrouded in mystery. This limitation isn't a flaw in our understanding, but rather a reminder of the profound depths that remain unexplored. Some interpretations suggest that all possible outcomes occur in parallel universes, branching endlessly through infinite dimensions of possibility. Others propose that consciousness itself plays a role in selecting outcomes, though no scientific consensus exists on such ideas. Still others suggest that the question itself might be meaningless, that asking why this outcome rather than that one is like asking why does blue look blue rather than red. The relationship between decoherence and the emergence of spacetime itself represents another frontier where understanding meets mystery. If space and time emerge from more fundamental quantum processes, as some theories propose, then decoherence might be operating at scales and in dimensions we cannot directly perceive. The familiar 3 dimensions of space and 1 dimension of time might be shadows cast by quantum decoherence operating in higher dimensional realms. Recent theoretical work has explored whether quantum gravity effects might cause fundamental decoherence that affects all systems regardless of their immediate environment. This speculative possibility suggests that the fabric of space-time itself might introduce limits to quantum coherence, creating an ultimate horizon beyond which quantum information cannot be preserved. While no evidence for such effects has been detected, the possibility reminds us how much remains unknown about the deepest layers of reality. The role of consciousness in quantum mechanics continues to generate debate and speculation among physicists and philosophers. While decoherence provides elegant explanations for quantum to classical transitions without invoking consciousness directly, some interpretations still propose that awareness or observation plays fundamental roles in shaping reality. These ideas remain highly controversial and unproven, representing frontiers where physics meets philosophy in ways that may never be fully resolvable through empirical investigation alone. As you contemplate these unresolved questions, notice how they might parallel the mysteries in your own conscious experience. The hard problem of consciousness, how subjective experience arises from neural activity, remains as puzzling as the measurement problem in quantum mechanics. Both involve the emergence of definite experiential reality from complex underlying processes that seem to operate according to different principles. The boundaries of our understanding also extend to the practical applications of decoherence research. While quantum technologies continue advancing rapidly, fundamental limits remain unclear. We don't yet know whether room temperature quantum computers will ever be possible, whether quantum effects might be harnessed for applications we haven't yet imagined, or whether there are fundamental constraints that will forever limit our ability to control quantum systems. These unknowns aren't obstacles to be overcome, but reminders of the inexhaustible richness of reality itself. Each answer we discover reveals new questions. Each solved mystery opens vistas of deeper mysteries. The process of scientific discovery resembles decoherence itself, possibilities continuously crystallizing into knowledge, while simultaneously opening new possibilities that weren't previously visible. The recognition of our limitations cultivates a healthy sense of intellectual humility. Despite remarkable progress in understanding quantum mechanics over the past century, the deepest questions about the nature of reality remain as mysterious as ever. We've learned to describe and predict quantum behavior with extraordinary precision, but the why behind quantum mechanics, the reason reality operates according to these strange rules, remains completely unknown. This unknowing isn't a failure, but a gift. It preserves the sense of wonder and mystery that drives scientific inquiry, while reminding us that reality is far richer and stranger than any theory can fully capture. The universe is not a puzzle to be solved, but an inexhaustible mystery to be explored, with each discovery revealing new depths of beauty and complexity. Understanding quantum decoherence offers more than intellectual satisfaction. It provides practical wisdom for navigating the uncertainties and complexities of human existence. While we must be careful not to overstate the connections, the principles revealed through decoherence research can inform how we relate to change, uncertainty, and the continuous process of becoming that characterizes both quantum systems and human experience. The recognition that reality emerges through environmental interaction suggests a fundamentally relational understanding of existence. Just as quantum systems cannot be understood in isolation from their environments, human flourishing cannot be understood apart from relationships, communities, and cultural contexts. This perspective encourages attention to the quality of our environmental interactions, recognizing that we are continuously shaped by and shaping the networks of relationship in which we are embedded. The selective nature of environmental decoherence, where certain patterns persist while others fade away, offers insights into personal development and growth. In your own life, you might notice how certain thoughts, habits, and ways of being prove robust against environmental pressures, while others naturally dissolve when subjected to the complexities of real-world interaction. Like environmental selection in quantum systems, life experiences help determine which aspects of personality and understanding prove sustainable over time. This understanding can foster a more graceful relationship with change and uncertainty. Rather than seeing disruption as purely negative, you might recognize how environmental challenges serve as selection pressures that help strengthen and clarify the most essential aspects of your character and understanding. The dissolution of unstable patterns, while sometimes uncomfortable, creates space for more coherent and resilient ways of being to emerge. The information processing perspective on decoherence illuminates the importance of learning and adaptation in human systems. Just as quantum systems process information through environmental interaction, conscious beings process information through experience, relationship, and reflection. The quality of your information processing, your ability to extract meaningful patterns from complex experiences, influences how coherently and resiliently you can navigate life's challenges. The irreversible nature of decoherence, which creates the arrow of time and preserves information about what has occurred, suggests the profound importance of choices and actions in human life. Each decision you make spreads information into your environmental networks, influencing not only your own future possibilities, but the possibilities available to others in your community. This perspective can cultivate a sense of responsibility and intentionality about how you contribute to the ongoing construction of social and cultural reality. The emergence of complexity from simple rules through environmental selection offers hope for addressing seemingly intractable problems in human systems. Just as biological evolution produces extraordinary complexity through relatively simple principles operating over time, human communities can develop solutions to complex challenges through patient attention to environmental feedback and adaptive learning. Consider how this might apply to personal challenges you're currently facing. Rather than seeking immediate solutions or perfect understanding, you might approach difficulties as opportunities for environmental interaction that will naturally select for more robust and effective ways of responding. The process of working through challenges becomes a form of environmental selection that strengthens the most functional aspects of your character while allowing dysfunctional patterns to naturally fade away. The quantum principle that measurement and observation participate in shaping reality, while not directly applicable to human consciousness, offers a metaphorical framework for understanding how attention and awareness influence experience. Where you direct your attention, what you choose to observe and reflect upon, influences which aspects of your experience become salient and which fade into the background. This perspective encourages mindful attention to the quality of your mental environment. Just as quantum systems are sensitive to environmental conditions, consciousness appears to be sensitive to the information environments in which it operates. Choosing to engage with uplifting, challenging, or meaningful content and relationships can influence the patterns of thought and understanding that emerge in your awareness. The understanding that reality emerges through relationship and interaction, rather than existing as a collection of isolated objects, can transform how you understand personal agency and responsibility. Rather than seeing yourself as a separate entity trying to manipulate an external world, you might understand yourself as a participant in the ongoing construction of reality through the quality of your interactions with others and with the world around you. As you reflect on these practical applications, notice how they remain grounded in metaphor rather than literal quantum mechanical effects. The principles revealed through decoherence research offer patterns of understanding that can inform human experience without requiring direct quantum effects in biological systems. The wisdom lies not in the mechanics, but in the recognition of deeper patterns that operate across different scales and types of systems. One of the most remarkable aspects of our exploration has been witnessing how understanding itself spreads and evolves through communities of researchers, thinkers, and curious individuals. The development of decoherence theory illustrates how knowledge propagates through intellectual networks in ways that parallel the environmental interactions we've been studying, creating an ecology of information that shapes human understanding over time. The story of decoherence research reveals how scientific insights emerge through collaborative, environmental interaction rather than isolated individual effort. The theory developed through the accumulated contributions of many researchers working in different contexts, each adding pieces to a gradually emerging picture of how quantum systems interact with their environments. Ideas proposed by one scientist were tested, refined, and extended by others, creating a network of understanding that no single mind could have developed alone. This collaborative process resembles environmental selection in quantum systems, where multiple interactions gradually select and stabilize certain patterns while allowing others to fade away. In the development of scientific understanding, the environmental pressures include experimental evidence, mathematical consistency, peer review, and practical applications. Theories that prove robust against these pressures persist and evolve, while those that cannot withstand scrutiny naturally fade from the scientific landscape. The spread of decoherence concepts beyond physics into other disciplines illustrates how powerful ideas naturally diffuse through intellectual networks, finding applications in contexts far from their original development. Researchers in chemistry, biology, computer science, and philosophy have discovered ways to apply decoherence principles to their own questions, creating new hybrid areas of investigation that wouldn't have existed without this cross-pollination of ideas. Consider how your own understanding has evolved during our exploration tonight. The concepts we've discussed have interacted with your existing knowledge, creating new connections and insights that are unique to your particular intellectual environment. The ideas haven't simply been transferred from one mind to another, but have undergone a kind of intellectual decoherence, adapting to the specific context of your understanding and experience. This process continues beyond our immediate interaction. The insights you've gained will propagate through your social and intellectual networks, influencing conversations, decisions, and further learning in ways that cannot be predicted, but that contribute to the ongoing evolution of collective human understanding. You become part of the environmental network through which knowledge spreads and evolves. The digital age has accelerated these information ecology processes, creating global networks through which scientific insights can spread almost instantaneously. Research published in one laboratory can be accessed and built upon by researchers worldwide, creating unprecedented opportunities for collaborative discovery and understanding. Yet this acceleration also creates challenges, as the volume of information sometimes overwhelms our ability to process and integrate it effectively. The principles of environmental selection become crucial in navigating this information-rich environment. Just as quantum systems naturally select for coherent, stable states, intellectual communities develop mechanisms for selecting reliable, useful knowledge from the vast sea of available information. Peer review, replication studies, and practical applications serve as environmental pressures that help distinguish robust understanding from temporary intellectual fashions. The ecology of information also reveals the importance of diversity in intellectual environments. Just as biological ecosystems thrive through diversity of species and interactions, intellectual ecosystems benefit from a diversity of perspectives, methodologies, and applications. The most significant breakthroughs often occur at the interfaces between different disciplines, where ideas from one field interact with concepts from another to generate novel insights. This understanding has practical implications for how you engage with learning and knowledge sharing in your own life. Rather than viewing knowledge as something to be passively received, you might approach it as an active process of environmental interaction, where new ideas are tested against your experience, integrated with existing understanding, and shared with others in ways that contribute to collective learning. The recognition that understanding emerges through environmental interaction also highlights the social responsibility that comes with knowledge. The insights you gain through study and reflection don't belong to you alone, but participate in the larger ecology of human understanding. How you choose to share, apply, and develop these insights influences the intellectual environment in which others learn and grow. As you consider your role in the ecology of information, notice how it parallels the environmental monitoring processes we've explored in quantum systems. Through your attention, questions, and reflections, you participate in the ongoing observation and measurement of reality that helps determine which possibilities become actualized in human understanding and culture. This perspective transforms learning from an individual pursuit into a collaborative contribution to the evolution of collective intelligence. Every question you ask, every connection you make, every insight you share participates in the ongoing process by which human understanding deepens and expands. You're not just learning about decoherence, you're participating in the decoherence of human knowledge itself, helping to select and stabilize the insights that prove most valuable for understanding reality and navigating existence. Throughout our journey into the depths of quantum decoherence, we've been engaged in more than mere intellectual learning. We've been practicing a form of contemplative science, a way of engaging with complex ideas that transforms not just what we know, but how we know. This transformation of awareness itself might be understood as a kind of cognitive decoherence, where abstract possibilities crystallize into lived understanding through the environmental interaction of ideas with consciousness. The contemplative approach to scientific understanding differs from purely analytical learning in important ways. Rather than simply collecting information or memorizing facts, contemplative engagement involves allowing ideas to interact with the full range of your conscious experience, including intuition, imagination, and direct awareness. This holistic approach can generate insights that purely analytical methods might miss. Consider how your relationship with the concept of environmental interaction has evolved during our exploration. Initially, it might have seemed like an abstract physical process relevant only to laboratory conditions. But as we've explored its implications across different scales and contexts, the idea has likely become more personally meaningful, connecting to your own experience of how awareness emerges through relationship and environmental feedback. This transformation illustrates how contemplative engagement with scientific ideas can bridge the apparent gap between objective knowledge and subjective experience. While maintaining intellectual rigor and scientific accuracy, contemplative science recognizes that understanding is not separate from the conscious being who understands. The quality of your awareness influences both what you can perceive and how deeply you can comprehend what you perceive. The practice of contemplative science involves cultivating what we might call soft attention, a receptive awareness that remains open to unexpected connections and insights while maintaining focus on the matter at hand. This type of attention allows complex ideas to settle into consciousness gradually, like sediment settling in still water, rather than forcing immediate comprehension through analytical effort alone. This approach is particularly valuable when engaging with quantum concepts, which often challenge ordinary logical thinking. The strangeness of quantum mechanics can be better appreciated through contemplative engagement that remains comfortable with paradox and uncertainty. Rather than rushing to resolve conceptual tensions, contemplative science allows these tensions to remain present in awareness, sometimes revealing deeper insights that wouldn't emerge through purely analytical approaches. The rhythm of our exploration tonight has intentionally followed contemplative principles, moving slowly through ideas, pausing for reflection, and returning repeatedly to connections between abstract concepts and lived experience. This pacing allows for the kind of deep integration that transforms understanding from intellectual knowledge into wisdom that can inform how you navigate life's complexities. Notice how this contemplative engagement with scientific ideas might influence your relationship with uncertainty more broadly. As you become comfortable sitting with the mysteries and paradoxes revealed by quantum mechanics, you might find yourself more at ease with the uncertainties and ambiguities that characterize human experience. The practice of contemplative science can cultivate a kind of intellectual courage that remains curious and open, even in the face of fundamental unknowing. The transformation of awareness through contemplative science also reveals the participatory nature of understanding itself. You are not passively receiving pre-existing knowledge, but actively participating in the ongoing construction of human understanding through your attention, reflection, and insight. The quality of your engagement influences not just your own comprehension, but contributes to the collective evolution of how these ideas are understood and applied. This participatory dimension connects contemplative science to the environmental interaction processes we've been studying. Just as quantum systems cannot be understood apart from their environmental relationships, scientific understanding cannot be separated from the conscious beings who engage with it. The observer is always part of the system being observed, the understander part of the understanding being constructed. The art of contemplation also involves learning to hold multiple perspectives simultaneously without collapsing them prematurely into single interpretations. This parallels the quantum superposition of multiple possibilities existing simultaneously before environmental interaction selects specific outcomes. Contemplative science cultivates the ability to remain present with complexity and ambiguity until deeper patterns naturally emerge. As you continue to practice contemplative engagement with scientific ideas, notice how it might influence other areas of your life. The same qualities of attention that allow deep understanding of quantum mechanics, patient receptivity, combined with focused inquiry, can enhance your appreciation of art, relationships, nature, and the subtle dimensions of everyday experience. The transformation of awareness through contemplative science represents a kind of cognitive evolution, an expansion of human capacity to engage with reality in increasingly sophisticated and integrated ways. Each person who develops this capacity contributes to the collective evolution of human consciousness, adding their unique perspective to the ongoing exploration of what it means to know and to be. As our gentle exploration draws to a close, we find ourselves transformed by the journey we've shared. We began with a simple question about how quantum weirdness becomes classical reality, and we discovered something far more profound: that reality itself is not a thing, but a process. Not a structure, but a dance, not a destination, but a continuous becoming. Through the lens of quantum decoherence, we've glimpsed how the universe constructs itself moment by moment through environmental interaction and information exchange. We've seen how the same principles that govern the collapse of quantum superpositions also shape the emergence of galaxies, the efficiency of photosynthesis, and perhaps even the patterns of consciousness itself. The boundary between the quantum and classical worlds isn't a wall, but a threshold, constantly crossed and recrossed as reality emerges from possibility through the elegant choreography of decoherence. This understanding offers more than scientific knowledge. It provides a new way of relating to existence itself. You are not separate from the quantum processes that surround you, but woven into their very fabric. Your thoughts, your experiences, your sense of being alive participate in the same fundamental dance that transforms quantum possibility into classical certainty throughout the cosmos. In understanding decoherence, you understand something essential about your own nature as a pattern of information processing arising from the deepest principles of reality. The mystery remains as profound as ever, perhaps more so. Each answer reveals new questions, each solved puzzle opens vistas of deeper puzzles. But this endless depth is not a limitation, it's an invitation to wonder, to explore, to participate consciously in the ongoing construction of reality through the quality of your attention and understanding. Take this knowledge gently with you as you return to the world of everyday experience. Let it settle into your awareness, like quantum information spreading through environmental networks, gradually transforming how you perceive the seemingly ordinary miracle of existence. Your quantum possibility becoming classical reality, breath by breath, thought by thought, moment by moment. And in that becoming, you touch the very heart of what it means for anything to be real at all.